Good evening, namaskara, Vedantu Karnataka students. Welcome to the carbon copy, the replica, the most important paper which you should be seeing before you enter the exam hall tomorrow. So let's get started with the amazing, most expected, very likely questions for your tomorrow's second PU Karnataka State Board examination of 2025, the physics carbon copy with me, your captain Shreyas. Yes. ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? Let me know quickly in the chat box. Yes. ನನ್ನ ಹೆಸರು ಕ್ಯಾಪ್ಟನ್ ಶ್ರೇಯಸ್, your physics master teacher in in Bengaluru. Yes, right now I'm in Bengaluru and I am conducting all my classes here right from right from the heart of Karnataka. So let me know where are you from quickly in the chat box, because an amazing session is lined up. Quickly smash that like button and bega bega subscribe madi. Yes, bega bega subscribe madi. Yeah, let's begin with the class. I hope you are all able to see me, hear me. We are good, very good. Shir, Shri, Rita, hi Sani, Guru Prasad, Uzma, welcome, Possible 900, welcome Mohammed, Manvita, Seventy, welcome Shweta, good evening Virat, hi Adnan, very good, Sam too, very good, hello Aishi, Mysuru, wow, Belgav, amazing. So let's get with the first section, the first part. Oh, Gulbarga. Wow. Bijapur. Amazing, amazing, amazing. So let's begin, guys. Yep. So tonight I have scheduled one more session on popular demand. Let me also tell that to you. Okay. Where is it? Numericals. And tomorrow morning, 5 o'clock. Guys, let's see if you can make this 8,000 subscribers to 9,000 if you want the numericals to happen. I want to see in the next couple of hours, I want this 8.33K to go to 9K. If you do that, I will come in the morning. Or else then I'll be like, maybe numericals are not required for you. I want the channel to be shared to every single person out there. And by tomorrow, that 9K should become 10K. Then I will come in the morning, guys. Come on. Everybody do that right now. That is a challenge for all of you. That, I mean, it's not even a big challenge. It's a very simple thing. Yep. I want everybody, from every student from Karnataka, to be a part of this massive revolution which Vedantu has taken for us, for we, the people, Namma Karnataka, guys. So make sure you're subscribing right away, right now. Make this go up right now and share this channel link with every single person of your school, college, everywhere. Let's go. First question on your screen. The resistivity of metallic conductor dash with decrease in temperature. Quickly answer in the chat box. Yeah. What do you think will happen? Yep. It will definitely. What will happen? It will definitely, when you take a metal and increase the temperature, then what happens? The resistivity will increase. But when you decrease the temperature, the resistivity will decrease. So B is the correct answer. Okay, simple. It is proportional to it in a way. When temperature increases, resistance increases, temperature decreases, resistance decreases. For conductors. For semiconductors, it is exactly opposite. Next one. If you take an imaginary sphere of radius r around the charge, keeping the charge at the center, the work done to move the charge from point A to B. This is the imaginary sphere, this is the center. If you move along this path, what will happen? It is on an equipotential surface. It is an equipotential surface. So what happens on an equipotential surface? Well, there is no potential difference. If there is no energy difference, potential difference, there is no change in the energy, there is no work done. Hence, the answer will be 0. No, it is not option A. It is going to be option B. Got it? Straightforward. Awesome. Excellent. Next one. If the potential difference across a capacitor is doubled, then the energy stored in it. If you double the potential difference on a capacitor, what will happen? There is a direct formula. If you remember, the potential energy is half C V square. So energy is proportional to the square of the voltage. So think about it. If you double the voltage, the square of the voltage will become 4 times. So the energy stored in it will also become 4 times. Voltage doubles, square of double will be 4, quadrupled. Hence, the answer should be option B. Very good. Keep answering the answers in the chat box. Love to see all your answers. Keep it up. Mr. Vaibhav, Krutika Lahari, excellent Rishita. Very good. Siddhi, Nandita, Unnati. Yes, the class will be barely for 1 hour or so. Next question. Conducting circular loop of R carries a current. If it is placed in a magnetic field, the B is perpendicular to the plane of the loop. The magnetic force acting on the loop is. If you take any loop, circular, square, rectangle, whatever, if it is placed in a uniform field, then the net force is always going to be zero. So it doesn't matter what the shape is, it is always going to be zero, irrespective of the shape. They can give you rectangle, they can give you hexagon. Don't get confused. Answer is always zero for the net force. Torque will be there. Remember, torque is M cross B, MB sine theta, but force is always zero, net force on a loop. When the angle between the magnetic moment of a compass and the uniform field which is placed is 180, then what do you think about the torque? Is it maximum, minimum, etc.? Come on, my dear students. I want everybody answering quickly in the chat box. Is it in some kind of an equilibrium? When the magnetic needle and the uniform magnetic field are exactly opposite, that means B is here and the magnetic moment is here, this is 180 degree, then the torque will be zero, but the energy will be maximum. This means it is going to be in equilibrium, but maximum energy means it will be in unstable equilibrium. So the correct answer for this question is it is in unstable equilibrium. D option is correct. Very good. Rita, Aaron, awesome. Chaitra, very good. Very good, Ashu. Okay. Nisha, this is one of the most important papers, but do not forget the other papers also are there, all the other things. Fixed questions, very important. Passing package PDF, download it. Okay. 70 out of 70 marks, 2-3 markers, please check it out. HOTS question, please check it out. 100 plus MCQs, please check out the PDF. So use all these PDFs. Tonight, numerical questions, important. And tomorrow morning 5 o'clock revision, but that I will come. Numericals I'll do only if you smash that subscribe button, guys. I want everybody to hit this subscribe button now because we are putting in so much of hard work. Yeah, I mean, I see this number not going up. I feel very sad, disappointed. I'm doing so much for our Karnataka students, and you guys have to show that response. And yesterday also I showed you more than 60 to 70% of the students have not subscribed and they are watching the videos regularly. So please don't do that. Please subscribe, Madi. Okay. Thank you so much, guys. Next question coming up on your screen. Here it is. What does it say? If a current is flowing in a straight wire parallel to the x-axis and the magnetic field is there along the y-axis, then what will happen? Then what will happen? Come on, think about it. If the current is flowing parallel to the x-axis and the magnetic field is along the y-axis, Fleming's rule, guys, one is along x, one is along y, then the force will be along the z-axis. So z direction, where is it? D option. Fleming's rule, cross rule, anything, because that force is nothing but IL into B. So it will be the cross product of length into magnetic field. So it will come perpendicular to current as well as the field, which is in the Z direction. Next one, the Lorentz force on a charged particle moving in a region containing is the force on a charged particle in a region which contains electric field, magnetic field, both, or only crossed electric field and magnetic field. Now the meaning of the word crossed is it is perpendicular. What do you think? It should be perpendicular or only electric field should be there or both should be there? Yeah, so basically watching all the videos and solving it is enough. Yes, Nisha, that's what I said. Correct. That's exactly what you need to do. And NCRT, please read it, okay? NCRT questions, please just, the solved examples, please go through it. Model papers, sometimes they don't ask so much. I mean, in maths, it happened they did not use the model papers so much. So there are 3 model papers for your second PUC. Just go through it. I mean, you should have gone through it long time back, but in maths, they didn't ask much. So we don't know what will happen in physics. By the way, the correct answer is both electric and magnetic fields because the formula of force is Q into E, which is electric field force, and then Q into V cross B, which is the force due to magnetic field. So both electric and magnetic fields together gives you the net force, which is called as the Lorentz force. Yes, C option, correct. Below the two statements related to the magnetic field lines, first statement, magnetic field lines do not intersect. Second statement, the direction of the field at a point is unique. What do you think? This is very straightforward. Everybody should be able to spam and give me the answer correctly. Yeah, what do you think is the correct answer, guys? Yeah, magnetic field lines, will they ever intersect? No, right? They even electric field, gravitational field, nobody can ever intersect. So first statement is correct. And second one, the field, the direction of the field is always unique. Yes, definitely. Because whenever you have a magnetic field line, the tangent drawn gives me the direction of the magnetic field. Now, if by chance it happened that one of the field line intersected with another field line, then this is saying the field is here, and this one is saying that the field is here. So there is no unique direction. So then this definitely is not possible. So that is the reason why the first statement is correct, because whenever intersection happens, there is no uniqueness. So that is the reason why it cannot intersect. So both are correct, and it is also the correct explanation. So option A, perfect. You guys got A number marks, A1 marks, awesome marks. You're going to get perfect. Next question. Straight conductor length L moving in the velocity v in the direction of uniform field. Strength B is the magnitude of the EMF between the ends of the conductor. This is a question on motional EMF. Motional EMF, guys, come on. Motional EMF formula. If a conductor moving in magnetic field having length L and speed V, the EMF generated across the ends of that particular conductor, one will be positive, one will be negative when it is moving like this inside that magnetic field. Yes, it will be BLV. Direct question. Yes, option A. Awesomeness, awesomeness. Kudos to all of you. Next one, the electromagnetic waves with lowest frequency among the following. Lowest frequency, lowest energy, maximum wavelength. Gamma, UV, micro, radio. I mean, gamma is highly energetic, correct? Even for that matter, UV, not so much. Microwave, even less. Radio waves, the least energetic, isn't it? Yes, so radio wave should be the answer. How many of you said D option? Let's see. Yes, D is the correct answer. So radio waves have a large wavelength, microwaves slightly smaller, UV rays even smaller, gamma rays is the smallest wavelength, so highest energy, guys. That is the correct answer. Perfect. Next question coming up on your screen now. Unpolarized light passing through a Polaroid, intensity of the emerging light is. So if you have unpolarized light having intensity I naught, it passes through a polarizer. If it passes through a polarizer, the light which comes out also gets polarized. It will have intensity I naught by 2. This was unpolarized light. It will have vibrations in all the planes. This will have oscillations only in one plane. It will be exactly half of that intensity. So D option. Yeah. Yes, Nisha, they will come. There are high chances. So that's the reason why we are doing this. These similar models might come, not exact, but similar models. Okay. So moving on. Radioactive decay in which the helium nucleus is emitted is called radioactive decay in which helium nucleus is going to be emitted is called what? What do you call? Helium, doubly ionized helium. What is doubly ionized helium, guys? Everybody should know that term. Yeah, electron is called beta. Doubly ionized helium is called alpha. Alpha. Gamma is not even a particle. Gamma is electromagnetic wave. Yes, this is electromagnetic wave. Negative beta is basically an electron. Positive beta is basically positron. So this is nothing but electron. This is nothing but electron. This is nothing but the twin of it, but it is opposite in charge, positron. So this is nothing but helium double plus. That is what is alpha decay. Correct. Very good. B is the answer. Minimum energy to free the electron from ground state hydrogen. Everybody spam the answer in the chat box quickly. Yes, minimum energy required to release that electron. It is the energy of that electron, which is minus 13.6. So from minus 13.6, you bring it up. You bring it up and make it free. You ionize it completely. So definitely you need to supply an energy of 13.6 electron volt. Yes, very good. Awesomeness, guys. Yep. Let's move to the next one. In the figure, there is EV and EC, which are the valence band and conduction band. This is the valence band, which is completely filled. Conduction band is either empty or partially filled. Correspond to an extrinsic, meaning externally it has been doped. And you can see that line, because of which it signifies that there is some doping which is happening between those energy bands. So E is the energy state corresponding to the impurity present in it. The impurity present in it can be arsenic, indium, phosphorus, antimony. Come on, guys. What do you think it is? What do you think it is? Yes. What do you think it is? Everybody quickly spam the answer in the chat box. Yep. Yes, come on, my dear students. I'm waiting to see. I'm waiting to see. Come on. Okay, very good. People are confused now. Come on, guys. Yeah, which type of semiconductor is this? Which type of semiconductor is this? Is it P type or N type? Is it P type or N type? See, this will be basically an N type of semiconductor, and the kind of doping that should happen is for arsenic. Yeah, it is basically arsenic. Yes, corresponding to an extrinsic semiconductor. Rest all are basically your, yeah, rest all are basically your other kind. Yes, correct, correct. Okay, very nice, very nice. Moving on to the next question coming up on your screen. Ready for it? Chirag, just watch the lecture, man. Don't ask how many marks. Just watch the lecture. Next one. The average power dissipated in an AC circuit is maximum if the AC source is connected to. If the AC source is connected to what, will you get the power to be maximum? Obviously, the power factor should be 1. Power factor is 1 when you have purely resistive circuit. When you have purely resistive circuit, because that is when the cos phi will be 1, because the phi will be 0 degrees. The phi will be 0 degrees. Yes, the voltage and the current will be in the phase of the current. Correct. Let's move. Fill in the blanks, guys. Filling the blank kind of questions. Superconductors show what behavior? When an iron rod is inserted inside a coil, its self-inductance. Light from a sodium lamp passes through a sheet, then the intensity will be interaction with matter. Light behaves as if it is made of packets of energy. Principle of the working of the transformer is called. The options are here. Fill in the blanks. Even if the options are not given, still you should be able to do it. Come on, come on, come on, come on. Figure it out. All the answers, give it at once. I want all the answers to be given at once. Everyone. Yes. Come on. What will happen? Superconductors show diamagnetic behavior. Yes. This will be perfect. Diamagnetic. This will be basically diamagnetic behavior. Diamagnetic behavior. Yep. This interaction of matter light behaves as a packet of energy. What is that packet of energy called? Yep, that packet of energy, what is it called? Definitely, it is called as photon. Correct. It is definitely called photon, and photon is there right over there. The principle of the working of the transformer, that is mutual induction. That is mutual induction. Perfect. What else? What else? Come on. A light behaves as if, okay. Then if the light from an ordinary sodium lamp is passing through a polarized sheet, then the intensity of the light emerging will be the intensity of the light. Ordinary sodium lamp passes through a sheet. So what will happen? The unpolarized light will become polarized. So the light intensity will decrease. It will definitely decrease. Iron rod is inserted, the self-induction. What will happen to the self-induction? Iron is a ferromagnetic material. So definitely permeability will increase. So self-induction will also increase. So that is the answer to this particular question. Excellent day. Awesome. 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 Is that clear? Is that clear? No, it will not be dark, guys. Passes through a polarized sheet, then the intensity of the light will not become dark. It will just decrease because unpolarized light will become polarized. I intensity will become I by 2. So I by 2 is smaller than I. So it is decreased. It is not dark. A lot of people think the answer should be dark, and that is why you will get the wrong answer. Yeah, is that okay? Okay. There is no decreasing. I think decreasing answer should have been, option should have been there. That is wrong. So no, it is not dark. My bad. That is the reason why I think you got confused. Okay. No worries. No worries. Next, let's go to the two marker questions, guys. Quickly coming up on your screen. Here it is. Define the magnetization of sample. How is it related to magnetic intensity? Come on, everybody put the formula. That's all I want. And put the units. Magnetization. Magnetization is magnetic moment per volume. Magnetic moment per volume of that sample. Yes. And it is related to the magnetic intensity with susceptibility. M is XH. M is XH, or X is M by H. M by H. X is M by H. Yeah. So that is the formula. X is susceptibility. H is magnetic intensity. M is magnetization. How much magnetic moment is there per unit volume? Yes, magnetic moment has a unit of ampere meter square. Ampere meter square. Volume is nothing but meter cube. So therefore, this will just become having an unit of ampere per meter. Ampere per meter. That will be the unit of it. Is that right? Everybody, very good. Awesomeness. Yeah, magnetic moment per unit volume. Next, the amount of work done to bring a charge of 3 millicoulomb from infinity to that point is this. Find the potential. This is the definition of potential. Definition of potential. Work done to bring it from infinity to that point divided by the charge. Come on. Work done per unit charge. Work done 0.06 joules. 0.06 joules. Perfect. Then the charge value already 3 milli. Milli means 10 to the power negative 3. Can you see that? 10 to the power negative 3 is already mentioned over here. That's it, guys. So divide this with this. So if you want, you can say this is 6 into 10 to the power minus 2. 6 by 3 is 2. And you will get basically this as 20 volts. Yes, you will just get it as 20 volts. Those of you who did not understand the calculation, 0.06 divided by 3 milli. Milli is 10 to the power negative 3. So it will be 6 into 10 to the power negative 2 by 3 into 10 to the power minus 3. 6 by 3 is 2. And this will just become 10 to the power minus 1. So this will become 10 to the power plus 1, which is basically 20. So 20 volts is the answer. Everyone got it? Yeah. Awesome. Awesome. Moving on to the next one. Yeah, mention the uses of Polaroids. Come on. Quickly mention it in the chat box, guys. I want all the answers in the chat box. Few uses. In 2-3 words also, if you mention, it's okay. 2-3 words also. Yes, very important, most important questions. Definitely, Arjun. That is why at least few questions will come, right? So it will help you. If you are getting 50, you will get 60. If you are getting 60, you will get 70. If you are getting 0 marks, you will pass. So that is the reason why I'm doing this for all of you. Okay, come on. Sunglasses, correct? Very good. They are also used in the. They are also used in yeah, movie theaters. You would have watched 3D Avatar movie. Yes, sir. I saw, sir. Yes, sir. I saw very nice movies. Gravity. I saw Interstellar. I saw so many. Or sir, I saw Bahubali, sir. I saw KGF in 3D, sir. So all those movies basically they use those glasses. They are using polarizing materials. Correct. Yes. They are also used in filters in front of cameras. Yes, they are used in filters in front of movie cameras, or even photographers use those filters. They are having polarizing material. Also sunglasses to prevent the reflections which come from snow, sand, water, etc., so that it will cause less strain on your eye. Correct. Improve the color contrast in old paintings. Correct. That is also an application. So many answers are there. So you can put some 3-4 uses, more than enough. Yes, improving the color contrast, old paintings. Yes, that is also another application. Correct. Definitely. Okay. Window panes also you can use it, especially those outdoor window panes if they have polarizing material, but it is very costly. So then generally they do not use it so easily because it is very costly. Polarizer material are very costly. What is the meaning of binding energy per nucleon? Binding energy divided by the nucleons is called binding energy. Binding energy is the energy required to break a nucleus into individual protons and neutrons, which is called as nucleons. Binding energy per nucleon, that is by the atomic mass number, gives me the stability of the nucleus. If it is more, then the nucleus is more stable, whereas if it is less, the nucleus is less stable. It tells me how much binding energy is going to be required per nuclear particle. Per nuclear particle, that means either a proton or neutron. Okay, and it gives me the stability. Remember, it gives me what? The stability of the nucleus, not atom. Stability of nucleus. It is directly proportional to it. More it is, more stable it is. All right. Yes. Very good. Awesome. Awesome. You are a topper. Monkey, what do you mean by you're a topper? Just by sitting. See, if you have a tree, and if the monkey goes on the top, so then you will call that monkey a topper monkey? Hmm. What are you saying, bro? Okay. So moving on to the next question. Write the two limitations of Bohr's atom model. Bohr's atom model. Two limitations, not hypothesis, limitations. Yes, come on, my dear students, limitations. Many limitations are there. First of all, Bohr's model was not able to explain what? So many things it could not explain. It failed for even helium, lithium. It was not able to address higher atomic numbers. It failed. Only for hydrogen, it was still okay, right? It was also not able to explain something called as the Z-man effect. Z-man effect is when the spectral lines which you get from an element, they start splitting more when you apply electromagnetic fields. That is called as Z-man effect. You apply electromagnetic fields, the spectral lines begin to, one line will split into 3, 4. How does that happen? It was not able to explain. Also, it does not explain why some lines are more bright than the other. It was not able to explain that also. Yes. Another important drawback is Bohr's model does not satisfy Heisenberg. Heisenberg says you cannot say I am in Bengaluru moving with 5 kilometers per hour in the traffic jam at Silk Board. You cannot say that, because if you tell me your speed, you cannot tell me where you are. If you tell me where you are, you cannot tell me what is your speed. That means momentum and position cannot be accurately predicted, but Bohr told exactly what is the radius and what is the speed, everything. So it fails to obey Heisenberg's uncertainty principle, where momentum and position can be simultaneously determined, cannot be determined actually. So these were some of the limitations. Here only two have been put. So you can put any of these two, you will still get marks. But if you feel that, sir, my two limitations not that great, you can put at most one, but generally it is not recommended because it is a 2-mark question. So do not put the third limitation. Even if you feel I'll get extra marks, you will not get. Okay, great. Moving on. The magnetic susceptibility is 1499. Find the relative permeability and permeability. Okay, guys, this is direct. This is very direct. What is relative permeability? It is 1 plus susceptibility. So what is 1 plus 1499? Come on, guys. It is 1500, right? So that is your relative permeability. And what is relative permeability? It is permeability by permeability of free space. Permeability by permeability of free space. Bring this gentleman on the top. So mu will become mu naught multiplied by 1500. Mu naught is 4 pi into 10 to the power minus 7 into 1500. Yes, 4 into 15. How much is it? Come on, guys. 4 into 15. That's 60. So 60. So you will have 6000 pi 10 to the power minus 7. If you want, you can put those zeros here. So it will become 6 pi into 10 to the power minus 4. 6 pi into 10 to the power minus 4. Correct? Everyone? Awesomeness. So that is what it is. And if you want, you can substitute the value of pi also. So in the end, you can also substitute the value of pi and give the answer in, give the answer in decimals. Yeah, the answer will be Henry per meter. You can put, different possibilities of units are there, Henry per meter, other things are also there. Like if somebody asks you what is the unit of permeability, magnetic field is mu naught, number of turns per unit length into current. So from this mu naught will be magnetic field into length divided by current into turns. So the unit of permeability will be Tesla meter per ampere. So Tesla meter per ampere is also correct. Got it? Yeah. Moving on. Sir, there is no PDF in the Telegram. Shreya, the problem is I cannot go into the future and take the PDF and come back in the past and give it to you right now. So please wait for the session to be over. After that, the session PDF gets uploaded, it processes, we upload it in our secure drive. So then the PDF link will be put in the description as well as in the comments. So you have to wait for the session to be over. Okay, the EMF of a cell is 2, internal resistance is 0.1, connected to a resistance of 3.9. Find the voltage across the cell. Come on, my dear warriors. Yes, bega. Answer, Heli. What do you think is the correct answer for this? So you have a battery, internal resistance and external resistance. So there will be some current in this. Current will be total EMF by total resistance. So total EMF is how much? 2. Total resistance is 0.1 plus 3.9, which is 2 by 4, which is basically 0.5 amperes. But the question is something else. Question is, what is the voltage across the battery? This is also called as the terminal voltage, and the formula for terminal voltage is E minus IR. EMF was 2, current was 0.5, resistance is 0.1. Yes, so it will be 2 minus, this will be 0.05, which is 1.95 volts. How many of you got 1.95? Let me see quickly. Very good. Awesome. Did you get 1.95 volts? Excellent, guys, if you guys got it. Moving on to the next question on your screen. These are 3-mark questions. Let's go, guys, quickly. Let's go quickly. Yep. To the next one, 3-mark questions. Derive the expression for the torque on the electrical dipole placed in a uniform field. Remember, the final formalized torque is P cross E. Remember, that is the thing. Magnitude is P E sine theta. This is what you have to derive. Check my derivation sessions. I have uploaded the PDF. Please by heart the entire derivation with the diagram. Very important question for tomorrow. Okay. So torque is P cross E, which is P E sine theta, and it comes from this diagram with the couple torque theory. State and explain Biot-Savart's law with a diagram. Biot-Savart's law, what does it say? The magnetic field due to a current carrying wire element is proportional to few things and inversely proportional to few things. What are those proportional things and inversely proportional things? Quickly let me know in the chat box, guys. What is it proportional to? Yes, if there is a wire carrying current, the magnetic field here will be proportional to the current. More current, more field. It's also proportional to the length of that element. Yes, the length of the element. It is also proportional to the sine of the angle between that element and the location where you are. If you join a line, so the position of that position of the point versus the length of the element, the angle between them, if it is theta, so it is proportional to sine theta where theta is the angle between the element and the position of the point. It is inversely proportional to the square of the distance between the element and the point. All these things, yes. Proportional to current, proportional to length, proportional to sine theta, inversely proportional to r square. Write it down point wise. This is dB, this is dl. dl is the small element, dB is the field due to that element. That is why that is also small. It is not b. b is big, dB is very small. And then you write it in the vector form. It looks like this, or in the scalar form, mu naught by 4 pi is the constant of proportionality. I dl sine theta by r square. What is the value of mu naught by 4 pi? The value of mu naught by 4 pi is nothing but 10 to the power minus 7. Yes, that is the constant of proportionality. Correct? So you write all these things and show a wire, show an element, show that distance r, and show the magnetic field, small field, which will be dB. You will get full answer, correct marks for that. Write the difference between dia, para and ferro. Come on guys, what all pointers can you think of quickly? Put it in the chat box. Many points are there. Out of them, who will repel the field more? Who will attract the field more? Yes, dia, go die. Repel. Dia will repel. Para and ferro. Ferro Rocher, best chocolate, best chocolate. So that's why ferro will attract the most. Para weakly attract. Yes, para will weakly attract. Correct. Yes, awesome. Okay, very good, very good. Then what else, guys? So many things are there. Permeability for ferro is very high. For para is slightly more than 1, and permeability for dia is less than 1. Susceptibility for dia is negative. For para is small positive. For ferro is very, very high. Yes. Then you can also say that when you heat a diamagnetic substance, it will not change the behavior, whereas paramagnetic behavior will slowly start reducing. You will see that as you heat the material, the magnetic properties will slowly begin to decay. It will slowly start getting affected by it. Ferro, nothing will happen until you reach the critical temperature. After critical temperature, which is the Curie's temperature, the ferromagnetic becomes paramagnetic. Yes, ferro becomes paramagnetic. Also, another important thing. Yes, another important thing. You can say ferromagnetism is based on domain theory. Paramagnetism is based on the magnetic moment of the atoms which are oriented. Diamagnetic is based on quantum theory. Yes, quantum theory, Faraday's law and Lenz's law. So that is what happens. These are basic points, but I have put up all the points over here. Strong attraction by ferro, weak attraction, repulsion by diamagnetic. Yeah, they will try to reduce the field. Here it will try to increase the field, and they will attract the field even more in ferromagnetic material. Yeah. So dia and para are temporary magnets. Ferro is a permanent magnets. Yeah, they are permanent magnets. Ferro. Permeability, susceptibility, and examples. Example of dia, copper, silver, gold. For para, it is like lithium, magnesium, sodium. So many things are there. Iron, nickel, cobalt are ferromagnetic materials. Yes, correct. Is that clear? Okay. Is that understood? All right, very good, very good. Moving on to the next question. Derive the expression for the motional EMF induced in a straight conductor moving perpendicular to the magnetic field. Yes, motional EMF formula, you should know the derivation. So you should take a C-shaped wire, move that wire and use Faraday's law. The area will change. As soon as the area changes, flux will change. Rate of change of flux is EMF. Use Faraday's law and you will get BLV as the answer. Please know this derivation and draw this diagram. Next, galvanometer can be converted into an ammeter. How? Ammeter measures current, but galvanometer cannot cannot bear a lot of current, so you have to bypass the current. Imagine there is a lot of traffic on a one road, or one road can only handle few cars per minute. So when too much traffic comes, what will the traffic police say? Bypass. Yes, he will whistle and he will say go from that side. So you have to bypass. Many vehicles come, you will bypass it. Same thing happens over here. So if a large current comes, you will not allow it to pass through the galvanometer. You will ask it to go from the other side. So for that, you need a shunt. Shunt means parallel resistance, which is very, very small. So when the current has two options, it will go through, more current will go through less resistance. So most of the current will go here. Very small current will go over here. Yes, that is the thing. This one and this one are in parallel. So you can say the voltage across both of them is the same. Voltage is current into resistance. So because the voltage is same, voltage is current into resistance, current into resistance. So current into resistance will be the same. That's how you get this formula. That's how you get this formula. Is this absolutely clear, my dear students? Excellent. Awesome. Awesome, awesome, awesome. Moving on. How can a semiconductor be forward bias? What happens to the width of the depletion region when it is in forward bias? Yes. How do you forward bias a semiconductor, guys? What is the connection? P is connected to what? N is connected to what? Quickly answer in the chat box. P is connected to what? N is connected to what? Quickly answer in the chat box, my dear students. Yes, for a semiconductor to be forward bias, for a semiconductor to be forward bias, P is connected to positive, N is connected to negative. Isn't that right? And when that happens, the diffusion current, the diffusion current, the diffusion current is more than the drift current, the drift current, and you will see the potential barrier is broken, it is overcome. You break the potential barrier is overcome. You overcome that wall, you overcome that wall, that potential barrier, and that is how you begin into conduction. So that is how you can make it forward bias, and the depletion layer becomes smaller and smaller. Yes, the depletion width will become smaller. Yes, so the depletion width becomes smaller. So earlier, if this was your PN junction, if this was your depletion zone, when it is in forward bias, the depletion zone becomes smaller. Yes, it becomes smaller and smaller. You are overcoming the barrier, and that external voltage is able to sustain that current. It is able to help you overcome that barrier or that wall. You are able to jump over it very easily. So that is the answer for that. Alpha particle, proton and an electron moving with equal kinetic energy. Which of them has largest de Broglie wavelength? Largest. Come on, answer in the chat box. What do you think? Largest de Broglie wavelength, guys. De Broglie wavelength is h by p. Momentum is root of 2 times m times kinetic energy. They all have same kinetic energy. So the one which has more mass will have less lambda. The one which has less mass will have more lambda. So you want the longest de Broglie wavelength. So the smallest mass. Who has the smallest mass? Alpha means 2 proton, 2 neutron. Proton means 1 proton. Electron much smaller than the proton. Yes. So the correct answer is electron has low mass. So it will have the largest de Broglie wavelength because all of them had same kinetic energy. So lambda was inversely proportional to root of mass, as we can see from here. Very good, Slayer. Awesome. Yes. Bula, these are the models of the questions. Models of the questions. Okay, cool. Shall we go ahead to the next one? Okay. What is the next question? Distinguish between intrinsic and extrinsic. Intrinsic means internal, extrinsic means from external. Intrinsic means it is the internal property. Extrinsic means it has been modified, adulterated, doped. Dope. Sir, it is very dope, sir. Yeah, so extrinsic is dope level. Intrinsic is no dope, internally peaceful, no need of doping. Yes. So, intrinsic is basically pure. It has not been doped. It is basically pure. Correct. Very good. Extrinsic semiconductor, you are mixing some impurity. Yes, you have doped it. You have added some impurity. Correct. Intrinsic, it is peaceful. So it will go normally. So the conductivity is low. The conduction is low. But when you add something adulterated, it will look very nice. Like the in the hotel, when you order some paneer, it looks so nice. The sabzi will look so cool, right? So it feels, oh my God, such nice colors, artificial colors. So it looks nice. So the conductivity is also very high. Correct. Yes. Here you will also see that the number of holes and the electrons are same. The number of electrons and the holes are going to be equal. But here extrinsic are of two types, N type and P type. So either the electrons will be more or the holes will be more. The number of electrons and holes are going to be unequal. That is very important. Most of the times you do not use this. Most of the times extrinsic semiconductors are used because conduction is low for intrinsic. Usually you do not use this. For extrinsic, they'll be used more often. Yep, very good. These are the main points. Secondary points are electric conductivity is function of temperature. Here the conductivity depends on the temperature as well as the impurity. So if you change the temperature, if you increase the temperature, conductivity will also increase because the resistance decreases. But here, if you increase the temperature, conductivity increases, but also more the impurity, more the impurity, more the conductivity. So here the conductivity only depends on the temperature, but here the conductivity depends on the impurity as well as the temperature. Both it depends on, both. Okay, so these are the things. These are the things which you should add. Okay, here the Fermi level lies in the middle of the valence band and the conduction band. Here the Fermi level shifts towards the valence or the conduction band. If you remember the energy band diagrams, there is an energy gap between valence band and conduction band, and that is the band gap. But when you add some doping material, then you will see an extra energy level is created between the valence and the conduction band. So that makes it easier for the electron to jump from valence band to conduction band, or that intermediate level. So that is another point. 5 mark questions. Quickly, let's have a look at it. Yes, PDF will be available later on. Okay, ready? Okay, what is the principle behind working of a MCG, moving coil galvanometer? Label the diagram, obtain the expression for deflection. I have told you this. So in India, we usually follow cricket, and cricket is associated with IPL. Similarly, football, very popular, obviously FIFA. Similarly, basketball, what comes to your mind? NBA, right? Basketball, NBA. And what do you never do with a basketball? You can dribble, you play with your hand, you should not hit it with your head, unlike football. You should also never kick. K for kick. You should never kick a basketball. Basketball, NBA, kick. And kicking is always done from below. Yes, so NBA by K. This is nothing but current. This is nothing but theta. So this is the final formula. This is that expression which we are talking about. This is that expression which we are talking about. You have to derive it. And what is the principle on which it is dependent? Yeah, it is based on the principle of torque acting on a coil carrying current. MB sine theta. MB sine theta. That is the formula. So basically, torque is nothing but M cross B. So it is based on this, where this is magnetic moment of a coil carrying current. Coil carrying current. It has some area. It has some area. It will develop some magnetic moment, some north pole, some south pole. It will develop some magnetic moment. So it is based on the principle of the torque acting on a coil carrying current placed in an external field. That is what it is based on. Okay, so let's see. The working principle is based on the fact that when a current carrying coil is placed in a magnetic field, it experiences a torque, which I just told you right over here. Next thing, you have to start deriving it. The entire derivation is here also, as well as, I'm not sure if you have seen this. This is the most important video, all physics derivations. And tomorrow you will realize, oh sir, I should have watched this. Please watch it. Everything is there here. How to derive it. Yes, please watch it. And the final formula which you get, exactly what I told you. Yeah, theta is NBA by K into a current. So usually we give for theta proportional to current. So that is what I have done. Okay, and if you are wondering what these are, N is turns, B is field, A is area, K is torsional constant, I is current, theta is the deflection. So eventually you prove that the theta over here is directly proportional to the current in that galvanometer. So this is the expression which you have to prove from this MB sine theta. That is what it is. Diagram also very important, given in your NCERT. Please check it out. Obtain the condition for balancing of Wheatstone. 100 times I have told you this, that please remember the Wheatstone's bridge and the balancing condition and how to derive it. So Wheatstone means, remember, Kaju Katli. Yes, Kaju Katli. And in between, you add some resistor here, add some resistor here, add some resistor here, add some resistor here, and there is some battery over here. In that Kaju Katli, what you are not allowed is, you cannot cut the Kaju Katli. That means this resistor is not needed, because there is no current in it. And when that happens, it is said to be balanced Wheatstone, and that happens when this R1 and R2 and this R3 and R4 are in a ratio. R1 by R2 is equal to R3 by R4. So that is the balancing condition. And to prove that it is balanced, there is no current, you have to assume the currents over here, it will split in these two branches like this, and use Kirchhoff's voltage law to prove it. Yes, for the proof, use Kirchhoff's voltage law. this loop, then maybe this loop, then maybe this entire loop. So 3 loops will be needed. 3 times you will have to use Kirchhoff's law and you will be able to get it. Yes, so that is the logic for it. Again, I have derived it over here as well. Okay, very important derivation. Please go through it. Okay, it's simple. 3 times you have to apply Kirchhoff's law. That's all. All right, cool. Yes, yes. Moving on. Next question. What is rectification? Explain the working of a full wave rectifier. Rectification. Come on, quickly answer in the chat box. What is rectification, guys? What does it convert from? To what? Yes, rectification means AC to DC. Very important. AC to DC. Full wave rectifier circuit diagram. Very important. This diagram, 2 diodes. For full wave, 2 diodes, half wave, 1 diode. For full wave rectification, this negative part will come on the top. This positive part will always stay. During positive cycle, D1 is forward bias. During negative cycle, D2 is forward bias. In both the cases, the current in this resistor will always be in the same direction. So you convert that AC, which is changing the direction of current, into DC, which is unidirectional current. It will not change the direction. Very important. Defining work function, photoelectric effect, and Einstein's equation. Yes, Einstein's equation. Come on, revising quickly. What is work function? To suck out that electron from that atom. Yes, to suck out that electron from that atom, whatever energy is required is called as the work function. It depends from material to material. Yes, what is the meaning of photoelectric effect? We'll come to that also. So first of all, work function is the minimum energy required to liberate the electrons from the metallic surface. That is called as the work function of that metal. Next, what is basically photoelectric effect? When light falls on a metal, and if the light's photons are of higher frequency, then electrons are ejected, which are called photoelectrons. The entire phenomena is called photoelectric effect. The phenomena of emission of free electrons from a metal surface when light of some suitable high frequency is incident, that is called as photoelectric effect. Yes. What is Einstein's equation? Einstein's equation, it says that the energy of that photon is work function plus K max. This is that equation. Yes, you can also write HF, H into frequency, is H nu naught. This is threshold, is half m maximum speed square. Either this or this. That is your Einstein's equation. Then you need to explain everything. This nu is frequency of the light. It should be more than nu naught for the electric effect to occur. If it is less than the threshold, no photoelectric effect. Kmax is the maximum kinetic energy given by half m V max square. Yep. All these things you should mention in detail line by line. What is H? H is Planck's constant. What is M? Mass of the electron. What is phi? It is the work function. Every single thing, mention it in detail. You will get full marks. Magnetic field due to a loop. Yes, magnetic field basically due to a loop on the axis. This is a long derivation. If you want to skip it, you can skip. If you can't visualize, otherwise, please learn it properly. You have to take that entire loop, draw that axis. Magnetic field will come due to every element in this direction. You have to take the components of this particular field, x component, y component. The y component will cancel, x component will add. The y component cancels because of this element there is a y component here. Because of this element the y component will be here, so they will end up cancelling. And then when you add up all the magnetic fields in the x direction due to all the elements, you will get the net magnetic field. Again, that derivation has been done over here. Please check it out. It is there, properly done. So please check it out. So this derivation, again, very, very important. Final formula is nothing but this. It is mu naught. If you want, I'll write it over here. It's there. Mu naught by 4 pi, 2 pi I r square by r square plus x square raised to 3 by 2. That 3 by 2 power will come in the denominator. Next, two charges placed at the corners of an equilateral triangle ABC. Find the magnitude and the direction of the resultant field at point C. Okay, this problem let's solve. Let's solve, guys. Everyone. Okay. Let's solve this, guys. So let's draw a triangle. Let's draw a triangle over here, and the charges are placed. 2 point charges, 2 coulomb are placed, plus 2 coulomb are placed. Question is, what is the electric field at the point C? And the side length is also given. How much is it? 0.2 meter. So because of this charge, the electric field will be here. Because of this charge, the electric field will be here. Let's say I call this E1. This will be also E1 only. The resultant will be like this. This is the net electric field. Now the net electric field will be by vector formula root of E1 square plus E2 square plus 2 E1 E2, here E2 is E1, into cos of the angle between them. This is equilateral, so this is 60. So even this is going to be 60 degree. So this will be cos of 60 degree. This is your vector addition formula. Resultant is a square plus b square plus 2ab cos theta, whole thing under the root. These are two vectors being added. Electric field is a vector quantity. That's it. Now you will get the answer. What is E1? It is nothing but 1 by 4 pi epsilon naught, or k q divided by r square. Here k is 9 into 10 to the power 9. Q is basically your charge, which is there, which is 2 coulomb, upon distance, which is nothing but 0.2, and this will be whole square. That's it. That is what your E1 will be. And before going ahead, let me also show you an interesting thing. Over here, what will happen? Cos 60 is half. So 2 will cancel. E1 square, E1 square, E1 square will come 3 times. This will become 3 times of E1 square. So you can take out E1 outside and put root 3 over here. This is the value of E1, kq by r square. kq by r square. So multiply by root 3, you will get the answer. Yeah, so that is exactly what they have done. And the final answer over here, I think, I think one slide is missing. I'll add that later on. Yeah, so just put over here, you will get the total electric field. So 9 into 10 to the power 9 into 2 divided by 0.2 square, which is 4 into 10 to the power minus 2 into root 3. This is the final answer, guys. So 2 and 4 cancels, becomes 2, and so this will become basically 9 root 3 divided by 2. This will go on the top, and this will become 10 to the power 11 Newton per coulomb. Yeah, everybody, that's it. Perfect, perfect. Root 3 will also be there. Root 3 will also be there. Correct. Yes, very good. Excellent. Do not forget to write root 3. Sir, to write loss, does statement alone enough, or should we also write explanation? See, inventory GMMS, if it is a 2-mark question, only the law with a small diagram enough. Better to give an example if it is there, else ignore it. If it is 3 marks or higher, then like in this question, explain photoelectric effect, right? All these things, define work function, etc. You have to write this and anything else related to that. Einstein's photoelectric equation, explain all the terms. If it is a big 5-mark question, explain the terms. If it is 2 marks, no need to do that. Is that okay? Next one. Batteries are there, 3 volt, 4 volt, internal resistance 1 mega, 2 ohms, 1 ohms, connected in parallel so as to send the current in the same direction through a resistance of 5 ohms. Find the voltage difference across the 5 ohm resistance. Yes, come on. Now, how to do this particular question? Let's start with a diagram first. So we have a battery, a resistance, another battery, and internal resistance. Together, they are connected across an external resistance like this over here. Now, this is basically 3 volt, this is 4 volt, this is 1 ohm, this is 2 omega. Omega is the symbol. External resistance is 5 ohm. That's what we have taken. And that is what they have asked now. Find, yes, how root 3 came in the previous thing. Okay, I think you missed this part. E1 square, E1 square, E1 square. What is cos 60? What is cos 60? It is half, right? So what will happen? This 2 and this 2 will cancel. So E1 square, E1 square, E1 square came 3 times. So 3 E1 square will come. 3 even square will come. Even you take it outside, it will just become even, and root 3 will remain as it is. Just the value of even is this much. Just the value of even is this much. You have to multiply by root 3. Yeah, that's why that root 3 came. Got it? Everyone? Okay, Larry? Understood? Clear? Yeah? Okay, perfect. Now, first of all, these are two cells in parallel. So find out everything as if you have converted into one single battery, one single resistance, and now that is connected to your regular 5 ohm resistance. So what is that EMF etc. going to be? First of all, that effective EMF will be E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. That is the formula. EMF 1 3, resistance 1, EMF 2 4, sorry, 4, resistance 2 by 1 plus 1 by 2. So this will be 3 plus 2 divided by 3 by 2. 1 plus half is 3 by 2. So that will become 5 by 3 multiplied by 2, which is 10 by 3. So this is basically 10 by 3 volts. Okay, so 10 by 3 volts is done. Everybody fine till this point? Everybody fine till this point? Yes, very good. Next, find out the equivalent resistance internal. So 1 by R is equal to 1 by R1 plus 1 by R2. So it will be 1 by 1 plus 1 by 2, which is 3 by 2, that is 1 by R. So R will be 2 by 3. So this will be 2 by 3 ohms. 2 by 3 ohms. Okay, next is finding the current in the circuit. Once this is done, because we have to find voltage difference. So current will be the EMF divided by the total resistance. EMF is 10 by 3. Resistance is 2 by 3 plus external, which is 5. So it will be 10 by 3, and 3 5s are 15. 15 plus 2 is 17 divided by 3. 3 cancels. So 10 by 17. So current is basically 10 by 17 amperes. But that's not the question. Question is finding the voltage. Question is finding that voltage. Voltage is current into resistance. Current is 10 by 17. Resistance is 5 ohms. So it is 50 by 17 volts. Voltage is 50 by 17 volts. Everybody clear till this point? Awesome. That's how you do it. Yeah. So 50 by 17 volts, which comes out roughly as 2.9 volts. Yes, which is basically 2.9 volts, because 17 threes are 51. So it's slightly going to be lesser than 3, which will be 2.9 volts. Cool. Understood? Give me a thumbs up, guys. Give me a thumbs up if you guys understood this. Moving on to another question. Yes, we have a LCR circuit question. LCR circuit, EMF is given, capacitance is given, resistance is given. The current in the circuit will be maximum when the inductance is. So if you want the current to be maximum, that means it will be resonance. It will be resonance. Yes. So omega will be 1 by root LC. So omega square will be 1 by LC. So L will be 1 by omega square C. So L will be 1 by omega. What is omega? Omega is 100 pi. So 100 pi whole square into capacitance already given. How much is it? 2 micro. Micro means 10 to the power minus 6, guys. So this will become 10 raised to 4 pi square into 2 into 10 to the power minus 6. Yep. So 10 raised to 4 and 10 raised to minus 6 will make it 10 raised to minus 2. So it will become 10 raised to 2 on the top, which is 100. 100 by 2 is 50. So 50 by pi square. Now that 50 by pi square Henry is the correct answer. Yes, 50 by pi square Henry is the correct answer. Cool. Shall we go ahead to the next one? Moving on to the next question coming up on your screen. Monochromatic source emits light of certain wavelength. Power output is 25 watts. Find the number of photons emitted by this particular source in 5 minutes. In 5 minutes. Okay. How to do this particular question? You have to find the number of photons. Is somehow number of photons related to the energy of the photon and the total wattage somehow? I think it is. What is the logic? Power is total energy in total per unit time. Now the total energy is number of photons into energy of each photon upon the time. So find the number of photons in 5 minutes they have asked. So we have to find n basically. So therefore our n value will be Pt by energy of the photon, which is P into T. Energy of a photon is hc by lambda. So that's it. Therefore n will be power. Power is how much? 25 watts. Time is how much? 5 minutes. Each minute is 60 seconds. So that's the time. Lambda is 500 nano. Nano is 10 to the power minus 9. The whole thing divided by h, which is 6.6, 10 to the power minus 34. That is your h. Multiplied by c. Speed of light is 3 into 10 to the power 8. So solve this, you will get the answer for the number of photons. It comes out 1.8 10 to the power 22. Yes, 1.8 10 to the power 22. So these many photons are emitted in just 5 minutes. It's a very large number. Yes, very large number. Correct. Let's go. Last question coming up on your screen. Already answer given. My bad. Two capacitors are connected in series across 300 volts. Find the charge, potential difference, energy stored, potential and potential energy in the capacitor. Okay, everything you have to find basically. Nothing great. I mean, see, because it's a 5-mark question. So 2 microfarad and you have, what is it? 3 microfarad, and both of them together are connected in series across a 300 volt source. So first thing to do is find the effective capacitor in series, which is 1 by C1 plus 1 by C2. 1 by C2. So CS is C1 C2 by C1 plus C2. So 2 into 3 by 2 plus 3. 6 by 5 microfarad is the effective capacitance. Once I get that, I can find the charge stored on it. So the total charge is capacitance into voltage. So 6 by 5 into voltage, which is 300. 5 goes with 300. 60 times 6 into 6, 36. So 360 micro coulomb. So that is the charge. So 360 micro coulomb, because this was 6 by 5 micro. So 360 micro coulomb is the charge. Now in series, what happens? The charge is going to be the same. So therefore, the charge on 2 and charge on 3 will be Q, which will be 360 microcoulomb. 360 microcoulomb. Everybody fine till this point? Yep. Very good. Awesome. Yes, correct. Oh, sorry guys. I think I took the second capacitance as 8 micro. Sorry, instead of 8, I took it as 3. I'm so sorry. When I looked from here, I didn't see this part. I just saw this part because of the reflection of light over here. So sorry. This was supposed to be 8. I will have to redo. My bad. Yeah. Okay. So this will be nothing but, and here also I wrote it as 3 while looking over here. So sorry. This was 8 microfarad. Yep. So this was nothing but 2 multiplied by 8 by 2 plus 8. So this will be 16 divided by 10, which is basically 1.6 microfarad. Now the charge will be capacitance into voltage. Capacitance is 1.6, voltage is basically 300. Take 1 0 out, 16 3s are 48. So it will be 480 microcoulomb. And in series, charge is always the same. Charge is going to be the same. So the charge on 2, charge on 8 will be this, which is 480 microcoulomb. That is the first thing that we investigated and we found out, calculated. Yeah. Everyone filed till this point? Okay. So we found out the charge. Then next is potentials. We have to find the potentials. Now voltage across 2 will be charge divided by capacitance. Charge is 480 micro. Capacitance will be 2 micro. So how much will it be? 480 divided by 2, that is going to be 240 volts. 240 volts. Similarly, voltage across 8 will be charge on 8 by capacitance, because Q is CV, V is Q by C. So this will be again 480, capacitance is 8. This is micro, this is also micro. So this is just going to be how much? 60 volts. So this is going to be 60 volts. So we found out the potential, we found out the charge. Now you just have to find the energy. The last thing, half CV square formula you can use, and you can easily get the energy. So energy in the second capacitor, 2 microfarad, you can use half CV square or half Q square by C, up to you. So half capacitance, which is 2 micro, into voltage. Voltage is 240 whole square. Whereas energy in the 8 micro, again half into capacitance, which is 8 micro, multiplied by voltage, which is basically 60 square. How much is it going to come out to be? Come on, my dear warriors. Yep. Everybody, how much is it coming out to be? Quickly, let me know in the chat box. Yo, come on, everyone. Tell me quickly in the chat box. 2 will cancel. 24, square it. What is the square of 24? Yes, 576. Correct. Yes, so this will be 576. But there is a micro over here. 57600. This will be microjoule. Here, what is it? 4 will be there. 6 square is 36. 36 multiplied by 4. 36 multiplied by 4. Come on, my dear students. Don't spam unnecessary things. 36 multiplied by 4. How much will it be? 34 is 120. Yes, 6 4 are 24. So 144. Yeah, 144. 144 and 2 zeros, microjoules. Correct. Yep. Perfect. That's what we have done. We have found out individual energies. If you want, you can find total energy also. Excellent. Excellent. So that's how you solve these questions, guys. Understood? So that was what was needed in this particular question. All these things were given. Perfect. So that was the end of the class. We will do some numerical questions. I'll give you some numerical questions at night, because I have a class right now at 8 o'clock in some other batch. So that's the reason why I cannot come early, or else I would have come out at 8 o'clock only. So give me some time. I'll be there at night, 11 o'clock, for all of you, for giving you that. But that is only if you hit this particular subscribe button. I want to see this go up. Or else then why should I come in the night? Yeah, I will start thinking. Come on, make this go up right away right now. I want this to reach 9K before I come. And or else I won't be able to come in the night and come in the daytime. I want to do that. Okay, quickly. Let's see whether you accept this challenge or not. Thank you so much. Have a great time. The PDF of this session will be shared shortly. Bye bye. Take care.